replacing the door switch today. We'll do that. Okay, so what's wrong? Well, it runs forever. And as you can see how it's starting to ice up all around it. That's what happens when it runs forever. So it turns into a giant block of ice. And the reason behind this is because it shuts off, and it actually shuts off the refrigeration. There's a solenoid up there too. It shuts off the refrigeration to the actual thing, to the actual coil, shuts off the fans. And the reason it does that is so it doesn't just continuously ice up. And this happens because when you open the door, all the moisture rushes in. And so if it's off, the moisture won't be attracted to the coils, won't cause the ice up. This is kind of a big deal because their store's closer to the ocean. So it's more prevalent over here. As you can see, it's starting to actually hang down a little bit. Not good. So basically what I had to do was, why'd this happen? Somebody power washed the switch. Okay, I came out in the middle of the night. The fans weren't working. This whole box was like 30 degrees. Okay, they power washed it, shorted it out. So I had to override it to continuously be on. Now the fan switch came in. We're gonna replace it, see how it works, and we're gonna get moving. So just to show you how it's supposed to work, you got a lever right there, and it's supposed to be fans off, fans on, fans off, fans on, just like that. So when you close the door, the fans should turn on. When you open the door, they should turn off. So we're gonna go up there, take a look. So you can see we're on top of the cooler now. Kind of hard to see, but hey, we'll do what we gotta. Oh, I can turn on this one. There we go, even better. So now if we go over here, we can see, right, here's the contactor, right? And so this contactor actually works the opposite way. So when there's no voltage there, the contactor links this top to the bottom, and yeah, it links the top to the bottom when there's no voltage. And the reason why that is because if anything interrupts the voltage, or the voltage breaks or something, this will fail on. That's kind of like the whole hopefully it fails on type of thing, so the refrigeration keeps going. So anyway, so I separated those two in the thing so there's no voltage, but I just wanted to show you. So that door switch closes, it actually stops voltage to here. This falls down because of the spring, or pushes up because of the spring that's inside, connects the contacts, causes the fan, the solenoid, and then if it's in defrost, the drain pan heater to run in this particular case. Now I have seen it where that switch has to work the other way, and that switch actually closes the contact and connects it. So it could be wired in, normally open, normally closed. You gotta look, see what it does. So also I wanted you to see, I would prefer not to work on this live. Working on live is, you know, obviously not preferable, but so you can see that this blue wire right there is kind of grafted into this wire right there. So you can kind of see that it shares the same power as the fan. So if I go to the breaker and I turn off the fans for the grocery freezer, it should work. Right there, you got grocery freezer fans right there. Turn them off, we'll see what happens. No fans are running. Let's go test our switch. You can see this is what I had to do to manually keep it on. I'm going to test those for voltage. Nothing, good to go. So you can see, unscrewing this one, unscrewing this one, unscrewing this. So I'm going to take it out from there, take this whole thing out down there so I can kind of pry it apart and work on it. So we're going to have to loosen this guy up there, take off that little nut right there, bring it to my service cart, and we'll just work on it. So I was able to pry it from the wall, and now it just slides out like that. I just need some space to work. That was super stuck in there, so just kind of showing you channel locks, wrench, and you just, you know, now it's good to go. Okay, so now it's all apart. This is what we need to reuse. This is our new one. We'll evaluate it, move forward. This is our new lever arm as well. So just to kind of show you here, this came originally with it on there, so I took this thing off, turned it, posted it that way so it would be a similar orientation to that one. So as you can see how this works is basically this lever kind of moves and it pushes that little pad up and down, right? And then if you look in there, there's a little pressure thing right in there, and if you click it, click, see, so it connects the top contacts, the bottom contacts. Actually, the bottom contacts when it's in, the top contacts when it's not in. So I'm assuming this works similar. This is just the principle. If you don't know what you're doing, just take apart the old pot. Yeah, so unlike the other one, there's no spring in this one. So what I mean by that is, if you look at, this is position 1, and if we, it's kind of hard to do one-handed, but let's see if I can get it. You might be able to hear it. Click. That's position 2. So it just has 2 positions. So what we're going to have to do is we're going to have to start it in position 1, right? Whatever position this is, put that little, door lever on it, and as the door closes, it snaps it to position 2, and it doesn't give you any clear indication on what is position 1, what is position 2. Like there's no 1 or 2 or something. There's nothing that's written on it, to give me an implication of that. All that there is that, one of it is from 2 to 1 and the other one is 3 to 4. That's the way that it seems. So if we think about how a contact move, a contact just slid up and down. So in the first case, it'll be 1 to 2. In the second case, it'll be 3 to 4. So what we're going to have to do here is, in this position here, we're going to have to take continuity and see what spade terminals have continuity, and then we can switch it over, and what spade terminals have continuity, and then we have to connect it, to meet what we want to happen. So we do not get voltage when the door is closed, and we do get voltage when the door is open. So those of you who might have been looking at the switch, so unfortunately this is not the right switch. So you can see how it's 2 separate positions. So once it goes into this upper position, it never goes back when the door opens, or it never, does whatever. So unfortunately the manufacturer sent us the wrong switch when we gave them the information, so I had to go get the correct switch. And we can see that this switch now actually matches our old switch that we have, and it actually will automatically reset. I turn it that way, I let it go, automatically turns. Now with that automatic reset, this makes a little bit more sense here, because now we know what positions 1 and 2 are. So I'm guessing when it's on the reset position, so this is horizontal, that we now have, it's on 1 and 2, and then when it's vertical, this will go to 3 and 4. So, and we can verify that again on this guy right here. We can see 1 and 2. Currently it's on, actually these top 2, which I'm guessing those might be 1 and 2. I peeled off the piece, so and then we click it, it goes down to these other 2. So, and we can see how they're labeled on the other one and how it compares. Because of how this fits together, 1 and 2, 1 and 2, 3 and 4, 3 and 4. So you can see that that's how it fits together, and that corresponds to this little diagram down there. So as I mentioned, you're taking it off, now we're turning it sideways, putting it on like that. So I'm going to hook this back up to the conduit, and I'm going to put the wires on 1 and 2. Why? Well, because it defaults to that 1 position. So it defaults to the 45-degree angle that I'm going to put on that lever to. So when it defaults to that 1 position, it supplies voltage to that contactor. Now that contactor is normally closed. That means normally without voltage, it's normally, closed. Normally without voltage, it supplies power to the system. Now, with voltage, it actually opens, cutting power to the system. So what I'm going to do is I'm going to wire it in for 1 and 2, because we only want voltage when we don't want the fans running. So now it's on 1 and 2. Obviously going to verify, because that's just how I am. 1 and 2. We can hear that even the littlest movement causes that to click on. So you can see that's how much range of motion you need. Just a little bit of a turn, like 10 degrees. Okay, so now if you see right here, so now the door is open. Now all the power is killed, so this isn't like a test or nothing, but so basically the doors are open, the power should be going to the contactor right now, okay, causing the fans to stop. And now let's see if that pad makes it work. Oh yeah, that would activate this more than 5 degrees needed or 10 degrees needed, causing it to stop giving power to that contactor. So now let's test it. So now let's take a look. Running. Push the door open. Looks good to me. So hopefully you learned something today. Maybe not. I don't know. Please like, subscribe, and all that. Whatever you do. And that's how you do it. Have a good one.